All right, everyone can hear me okay? Excellent, excellent. This talk probably won't be as funny as my Ignite karaoke earlier, but hopefully it will be just as informative. So this is Generative DevOps. I am Cecelia Martinez. I am just up the road, or down the road in Atlanta, Georgia. There I help organize the Atlanta JavaScript and Out in Tech Atlanta meetup groups. I really love local developer communities. I really believe that they're the beating heart of tech. You can find me at Cecelia Creates on pretty much any platform, Twitter, GitHub, CeceliaCreates.com. I will be sharing these slides on my profiles after fact. You may also recognize me from last year where I did talk about testing. I've previously worked at companies like Ionic, Cypress, and Replay, so I'm really passionate about open source developer tools. I'm currently a lead developer advocate at OutSystems. So OutSystems is a full-stack low-code development and delivery platform for mission-critical applications. You can learn more about it at OutSystems.com, and it essentially features all of the things that you see here on the screen. Today we're going to be talking about AI. So I'd like to start by getting a sense of who is leading the AI initiative at your organization. So raise your hand if you have kind of a bottoms-up approach to AI, where people on your team are individually deciding what tools that you use or when AI gets integrated in your team. Couple of hands. Okay, now who here has leadership, so top-down, leading the charge for integrating AI into your development processes? Yeah. That's what I expected. That's what we typically tend to see, is that leadership is very focused on the integration of AI into software development. So from the Accenture Artificial Intelligence Summary Index, 84% of C-suite execs believe that they must use AI to achieve growth objectives. And on top of that, 75% believe that if they don't scale within 5 years, that they risk going out of business entirely. So there's a lot of anxiety at the top amongst leadership around not falling behind when it comes to AI. There's also a lot of expectations. So this chart comes from the Dynatrace State of AI report, and these are the top improvements that leadership expects AI to solve in their organizations. So 93% expect that the speed of software deployment and delivery will increase. 89% expect faster incident response. They also expect to extend data available to non-technical employees with natural language progression. And really even up to 79% expect to have security analysis productivity and teams' ability to predict and proactively resolve service-affecting issues. So, there's a lot. There's a lot of expectations, and the expectations are extremely high. So there's a lot of different ways that AI can intersect and integrate into the software development process, right? It's not just one place, and you can see that in this chart, that there's many different locations and places where they expect AI to be able to integrate. So at OutSystems, we have these 3 pillars of AI, which represent the different intersections of AI and software. The first 2 that we're going to talk about are the ones that tend to get the most attention. The first is AI-powered apps. So this allows you to build apps that use AI. So these are apps that leverage AI, whether it's via APIs or building out your own functionality. So over the past 2 years, we've seen countless apps pop up that are essentially a wrapper of ChatGPT, right? Like chatbots and, submit your resume and it'll optimize it for you, everything from that. There's also apps that leverage AI to analyze data, generate text and images, recommendation engines, suggestion engines. All of these are examples of AI-powered apps. At OutSystems, we have the AI Agent Builder, for example, that lets you build out AI apps quickly by connecting them to an AI model and then UI templates to build things like chatbots or service ticket resolution. Retrieval augmented generation is also optional by connecting an external data source like your help desk documentation in order to create applications quickly. All right, so the second pillar is what gets a lot of attention within developer circles as well, and that is development with AI. So this allows you to accelerate development and change using AI. The one that comes to everybody's mind is, of course, Copilot. So how many people here have used like GitHub Copilot when developing applications? I'm not surprised, so have I. And how many people here have used ChatGPT or something similar to ask questions and generate code snippets? All right, so that aligns with what the data says. And in addition to things like Copilot and ChatGPT, there's also kind of more low-code solutions, right? You have UI generation with V0, which is from Vercel, or also even the infamous Devin. Who here has heard of Devin? Yes, okay. So if you don't know Devin, it comes from Cognition Labs, and Devin is apparently, or is billed as, the world's first fully autonomous AI software engineer. Works on his own creating software using AI. They have about the same, I think, finish rate when it comes to GitHub PRs that I do, which is not great, but it's getting there. But for the still human engineers, like us, these tools are an augmentation of our existing development processes, and they're very, very, very popular. So here's an example of an AI-powered logic assistant. So OutSystems is a visual development platform, and we allow you to create out flows using a visual drag-and-drop editor. We use AI to make suggestions based on your existing data model, whatever UI components that you have, and any available functions and logic flows that you've already built out. We also have natural language data manipulation that lets you build out queries in a visual platform using natural language instead of having to manually write SQL queries. And 81% of developers are using AI-powered coding assistants like this. Now, this includes ChatGPT, so that's why the number is so high. It includes asking questions, but it's reflective of just how much usage of these tools has increased. There's also a lot of productivity gains that come with using these types of tools. So the ZBS State of Generative AI and Software Development report states that leveraging AI for development results in productivity gains of 10 to 50% depending on task complexity. So you get higher gains when it comes to simple tasks, and you get lower gains when it comes to more complex tasks. But still, 10 to 50% productivity is still quite a lot. However, these productivity gains, if they're only in software development and then only in code gen, can throw off the balance of your entire software development lifecycle if you have constraints elsewhere in your system. So say, for example, if the amount of code that you're generating is increased because your software developers are using tools like Copilot or other code gen tools, but the number of potential security vulnerabilities is also increasing because of that, and your process is not equipped to handle it. Or maybe your quality team can't keep up with the influx of new features and code, or if you're deploying more frequently, but incidents are increasing, but you're not really sure why, and you're not able to track down the roots of those incidences. This can all happen when AI is only implemented in one part of the software development lifecycle. So in a recent webinar about DevOps trends in the age of generative AI, Stephen Walters, field CTO at GitLab, said, "The real constraint potentially within your organization may be later on within your lifecycle. So how you're doing your deployments, how you're initializing your environments, and things like this, by speeding up the amount of work that's going into that constraint point, it creates a bottleneck, and you not only lose the productivity gains, but you could actually cause issues in the rest of your cycle that could slow down the entire process." So it's critical that if you're implementing AI in your software development process, that you're implementing it in a balanced way across your SDLC. And so that's when we come to the third pillar of AI, which is lifecycle management with AI. So this is optimizing your app lifecycle by leveraging AI. So this is something that we already kind of know that we need to be doing. 83% of DevSecOps professionals said that implementing AI into their processes is essential to avoid falling behind. But we don't necessarily know how to get started. Some of the common approaches that we see, the first one is AI as AI for everything. AI is a magic cure that we just want to stick it everywhere and see what works. The second approach that we see is AI as a disinfectant, where we say, what are the worst parts of our software development lifecycle, and let's use AI as a Band-Aid to fix that. Now, when it comes to these two approaches, there's a lot of different things that you need to consider. And the considerations when integrating AI into your lifecycle management is reflexive of the complexity of your lifecycle management as a practice. So it can be difficult to know where some of the more high impact areas are to start because you have a lot of considerations, like so many considerations that you need to think about. And these are just the ones that I thought of in the first 5 minutes, right? And so to kind of get a sense of what are the most high impact areas to implement AI, I kind of reached out to a development community to find out who in practice was leveraging AI into their lifecycle management and how it was impacting their processes. So I'd like to highlight some of the use cases and tools that I discovered across testing, monitoring observability, and continuous deployments, as well as talk about some of the implementation strategies that were used in order to integrate AI into lifecycle management. So I'll start with testing, my first true love. And the first use case comes from somebody who was leveraging AppVance.ai for test generation. Now, AI for test generation is not new. We see that even within Copilot. However, we typically see things that are tests that can be generated based on your code itself. So unit tests, potentially also API tests, things that can be inferred from your code. When it comes to functional and end-to-end testing, this becomes a lot more complex, levels of complexity higher. So that's where you need to leverage more advanced tools for this. So AppVance AI does this by using what's called a blueprint file. This is a proprietary file that's generated by essentially crawling your site. You give it your URL. You optionally can also give it information about the HTML tags and elements on your page. And it crawls your site. It learns about the functionality and the different pages and the different elements that could be used for testing. It creates this blueprint file. It takes that in combination with your server logs, which of course provides information about all your HTTP requests that are happening. And it uses that to essentially generate functional and API test scripts that run in a no-code way. The person that I talked to who was leveraging this, they were using it for new functionality and they were doing critical path testing with it. And they needed to be able to get the test up and running very, very quickly. And this is the tool that they ended up using. It does have also integration into CI/CD. So as you push new changes, it can create a new blueprint file and update the tests accordingly, as well as also run the existing tests. Another interesting area of testing and intersection with AI is synthetic data generation. So one of the hardest things to do with testing is setting up your data. Who here has struggled with setting up, maintaining test data? Yeah, I should see a lot more hands. Okay, and so synthetic data generation is interesting. It comes from the MIT Data Cibo Synthetic Data Vault. And essentially, it matches statistical properties of real data. So this is not just like mock data where you create a schema and it generates it. You can actually train this model to learn from your real data in terms of what types, what's the incidence that you should have of certain types of users. And the nice thing about that is not only for industries that have sensitive data where it may change a lot, or sensitive data where you can't use real data, but if you have data that changes a lot or data model that changes a lot, you can retrain instead of maintain. All right, so now we have monitoring and observability. This next use case comes from another OutSystems developer I spoke with who is using Dynatrace Davis AI. Has anyone here used this? Okay, cool. So this will be pretty new for everyone. It is new to me too. So Dynatrace Davis AI allows you to, essentially, you can consume logs via API, or you can also install the Dynatrace instance within your host. And it takes all of your logs and it uses them to have prediction-based anomaly detection. This gives you problem analysis for things that go wrong in your system. So this is made possible for OutSystems applications, and the user that I was talking to was doing this using log streaming. So we use the OpenTelemetry protocol in order to connect directly to Dynatrace. It includes all the application and platform logs for continuous near real-time streaming. So what that means is essentially you're taking all the application and data platform from the application. It's being converted to OTLP log data, and then for tools that do not require a collector, it implements directly. Otherwise, you do need to set up an open telemetry collector in order to connect to other types of tools that don't support that. And in OutSystems, you can set up log streaming very easily. This is how you do it with Dynatrace specifically. You just choose the protocol and you set up your API credentials. And that allows you to set up this Davis AI prediction-based anomaly detection. The important thing here is that in addition to statistical analysis, it's also learning-based analysis. So it takes time for it to learn about your system, but over time, it's able to understand things like unexpected low traffic based on activity from previous, and other things that you can help determine root cause analysis as well. All right, and then we have continuous deployments. So when it comes to continuous deployments, one of the integrations that I saw when it comes to AI was natural language CI/CD pipeline generation. So the tool that was referenced, the tool the person was using, was Reflection. But this is code generation. It's a web application that does a lot of different things. But one of the things that it does is it generates CI/CD scripts for GitLab CI, GitHub Actions, Bamboo, Circle CI, Travis CI, all the ones that you see on the screen here. And it kind of looks like this. This should play a video. Yeah, okay, cool. Where you just use a natural language, say what you'd like it to do, and it generates the script for you. So this is very similar to code gen. However, it can be leveraged across your DevOps continuous deployment processes. And it is a web app. However, there are other solutions that I have seen that are more API-based that you can connect with in order to generate based on that natural language prompt. So if you need to make a specific change to your CI/CD pipeline, you can do that in a natural language way without having to necessarily reconfigure the YAML that gets put out. And the other one is pipeline failure analysis. And so I imagine a lot of you are probably already familiar with this type of application of AI within your DevOps systems. It's available in a lot of different CI/CD tools, and it's also something that you can implement yourself if you need to. Essentially, it submits the build error and the log for analysis when something goes wrong and your pipeline fails. The root cause and solution recommendations will come from a model. However, you can also continually improve the recommendations that you get by augmenting that with continued use of your logs over time. So you can get better suggestions based on things that have failed in the past, as opposed to just a general, ChatGPT response that you would get if you just happen to take that error and punch it in. So one example of this is in AppFlow. So AppFlow is a mobile CI/CD deployment tool, and it has AppFlow Assist, where whenever a build fails, it will submit the build log as well as the error to an AI model, and then based on that will suggest a solution to resolve the error. Some of them are pretty straightforward. Dependency is missing or out of date, and it will give you a suggestion to how to resolve that, as well as provide references and links for how to resolve that solution. Now, I will say this example is something where it is a pretty straightforward. It's taking only the log and the error message from that specific run. However, if you were to implement this on your own, again, you could use RAG in order to have a data of like a repository of all your previous logs in order to help train the model over time to get better responses. All right, so that brings us to implementation strategy. We just looked at a couple of different real-world examples from developers that I've talked to who are leveraging these solutions within their software development lifecycle. But the way that they did this was, not just a pick something, implement it, and hope for the best. They all had a pretty similar strategy for how they approach this. So when we think about implementation strategy, there's a couple of things to remember. But here's the general outline of the steps that you should follow. The first thing to do is to assess your workflows and specifically identify existing limitations. So you need to think of AI as an accelerator. It's not a magic fix-all. It's also not a Band-Aid, but it will accelerate what is already happening. So what areas across your software development lifecycle will benefit from acceleration? So it's not necessarily a bad idea to start with the worst performing areas, but you need to understand why that they're your worst performing areas. Is it a problem that can be fixed by accelerating that workflow, or is there another problem, is there an organizational, a structural, a data issue that needs to be fixed before you integrate AI? You also need to identify where in the workflow it makes sense to apply these accelerators. In some of the examples that we mentioned earlier, right, if an influx of code changes is occurring due to code generation, but your bottleneck is in testing, then maybe something like AI test generation could make sense. And that may make more sense than starting with continuous deployments, which is further on down that workflow. So this is all going to depend on your existing limitations as well as your existing culture. So what changes need to be made before you can implement AI? Do you have the training and security and change management already in place and the infrastructure requirements that are needed? One area that we see a lot of concern around is skilling, is making sure that your team has the skills needed to ensure that the output from AI tools is on par with all of your existing quality standards. So that may be something where your team needs to be on board for that acceleration that will take place. I mean, this is essentially a digital transformation, and you should tailor your implementation strategy with that mindset. This is a digital transformation, and everybody needs to be on board. Ultimately, this is all about risk management when it comes to governance and guidelines. So legal, compliance, and security teams will need to establish governance policies related to all the data that goes in and out of AI tools, who has access to these tools, and also establishing guardrails for how integrated these tools are with your existing systems. Especially early on, it will be really important to be able to isolate these tools and how they interact with the rest of your system. If you need to be able to quickly remove that, roll back, and we need to also have very good documentation and logging for why certain things were generated and why certain decisions were made by the model. If you don't have that, then it's something that you should not move forward with yet. So a recommended approach is a phased approach that prioritizes integration with your existing system. Rather than creating additional silos that exist outside of your system, you want to be able to integrate into what you have now so that you can properly accelerate it, but create that level of isolation when needed to have those guardrails in place. All right, so thank you very much. If you're interested in checking out OutSystems, that this QR code is for, I also have, I'm not sure how much time I have left, honestly. The timer's not going, but I'm happy to answer any questions that anyone may have.
Awesome. We have some time. We definitely have some time.
I think I started early too, right?
Yeah, so,
okay.
And this is like a big topic, so I would imagine some of us have some questions. Yeah, oh, perfect.
Hi, great talk. By the way, yeah, I just have one question. When you said retrain rather than maintain, what did you mean by that?
Yeah,
and if you, sorry, a second part, if you can go back to the slide where you had OpenTelemetry and the source like Dynatrace, Elastic, so forth. Just, yeah. Okay, thank you.
I'll find it.
Good question. Retrain, was it?
Retrain instead of maintain.
That's it.
So again, coming from a testing background, dealing with test data is a very painful process where you're constantly having to maintain and update the test data that is generated in order to run your automated tests, right? So the idea with synthetic data generation is that when you make changes to your application, you can use real production data that has been scrubbed to train the model in order to generate that synthetic data that statistically matches what your production data would look like. So when you make changes, instead of having to go through and manually update your test data to maintain that, and usually there's a process around that to ensure that your test data is lined up with your expectations from your output from your tests as well as your application, you can instead just retrain that model briefly on your updated production data, and that will update the model to better reflect the current state of the application to then generate new test data. So you're letting the computer essentially do the work of relearning what the data should look like versus having to manually maintain all of that.
And just a quick note, the slides, all the speakers are submitting their slides to DevOps Days, and then we're going to combine them with recordings and post them on YouTube. So if you missed a slide, they'll be posted somewhere.
Yes, and I will also share the slides on LinkedIn and Twitter and all the things.
Cool. Any other questions? All right. Perfect. I'm running.
Yeah, so when you retrain the data, how do you coordinate that with your assertions in your test so that the newly retrained data matches up with those assertions and output of the test?
Yeah, so this kind of goes, this is like a more general testing kind of philosophy types of question, right? So your test should be deterministic in that it should not be a one-to-one match for whatever your data is generated, just in general, right? So you're generating data that you are then can use for your testing, but you shouldn't necessarily have it hard-coded in your assertions that it matches up with whatever that data is. So it's a couple different ways that you could do it. Again, this is probably a little bit outside of the scope of the generation of it, but some best practices are dynamically essentially grabbing the first user and then passing that through into your test so that you're making sure that at least the types and the schema matches up with what you're expecting versus hard coding all of that into your assertions. That's a general practice that I would recommend doing. Now, if you always have the same test data and your test data doesn't change very much, and it's okay, and you don't necessarily need to have a representation of your production data. So if it's not important to you that you have a certain subset of users that always kind of match up a certain percentage, or that you're ensuring that this type of application entity is represented in your test data, then it may not be the right tool for you if you can get away with just creating one type of data and using that indefinitely. But if you have a lot of dynamic changes to the types of data in your application that would need to be reflected in your testing, number one, that would be a use case for this. And number two, your assertion should also be dynamic towards more around the structure of the data. Good question.
We have another question?
So in the log analysis, I'm unfamiliar with this, so I might be wrong about what you were saying, but you're training the model a little bit on the code base as well as the log data. Is that true for some of these models?
Yeah, so the one that the person that in this case I was using was Davis AI. Mm-hmm. And so the model that they were using is that they were doing log streaming. So they were sending all the logs that are produced by the OutSystems platform over to Dynatrace, and that is what was being consumed, and that's what's being used against it. Another option that was available, I haven't tried this before, and the person hadn't done this, is you can also install essentially on your host, which will grab the data that way as well. But it's using all of that to essentially learn about everything of your application, and from that be able to make predictions around when something is happening, indicating when something could be happening, and then when something has happened, why that's happened. Okay. Does that answer your question?
Yeah, I mean, it would seem, because I know that it's difficult to it seems like there'd be a big volume problem if you were trying to compare the logs with the source code, because the source code contains a lot of information that's relevant to the model, but it's limited in text versus the logs are, so you'd have to normalize. You could probably normalize for that, but.
Yeah, so I guess a good thing to note is both the examples I talked about, the log streaming and then also the test generation, neither of those actually accesses the source code. Yeah, so the log streaming is all the logs that are coming from your application, and then the test generation is using your server logs and then a blueprint file that's created by interacting with your app. But it's essentially doing that via automation. So it's not actually seeing the underlying code. It's getting anything that you would be able to get from within a browser, all the different HTML elements, as well as the functionality of what you can interact with on the page. Good question.
Yeah, that was a good question. Any more? All right, another round of applause.
Thank you.
We're just gonna keep you on stage.